Number 1 says, given h of x is equal to the absolute value of x plus 2 minus 3, and g of x is equal to the negative absolute value of plus 4. Describe how to obtain the graph of g from the graph of a of x is equal to absolute value of x using transformations. So a of x is your, what we would call to the parent function. So how would we get from a of x to g of x? Faith. Reflect over x and what? And up 4 units. All right, describe how to obtain the graph of h from the parent graph. Right. So we would go to the left 2 units, and then down 3 units. Sketch the graph on the same coordinate plane. Ooh, that might be a little tough. Okay, so we're going to graph them. First of all, you're going to look at what? What do we want to look at first? You always want to look at your y-intercepts. So if we're looking at our y-intercept for h of x, where is it at? Okay, it would be at negative 3, but we have to shift it to the left 2 units, right? So that means that one's going to be at negative 2, negative 3. Right there. Okay. Then we could say, if we plug in 0, what do we get? What if we plug, or not if we plug in 0. If it is equal to 0, if x is equal to 0, what do we get? Not if x, not if x is equal to 0. How do you get negative 1? This 2 is, okay. So plug it in and we get negative 1. Now, since we know the vertex is going to be negative 2, let's plug in negative 5. Let's just say negative 5. If we plug in negative 5, we get what? We get 0, right? So at negative 5, 0, we have another point. All right, so now we can just graph those. Okay? Now, we got to do g of x. G of x, what is the y-intercept? 4. So 0, 4. Because we don't have any type of horizontal shift, so we can just plot it. Now, let's plug in negative 5, and what do we get? What do we get for negative 5? What's the absolute value of negative 5? So then we have a negative 5, right? Because we got to do the opposite of that. Plus 4 is negative 1. So Okay, now let's do positive 5. What do we get? -1 again, right? So 5, -1. So now let's do this. Let's do it in a different color. Let's do purple. There's your two graphs. Now, this is g of x. And if we go back to the blue, I don't know if that's the same blue or not, but this would be h of x. There we go, page 2. Oh no, it says use your graph to estimate the solutions. So if we go back up, or go back to page 2, or page 1, and look at the graph, what is the solutions? What does it mean by solutions? What is it, Sarah? There we go, where the two graphs intersect. So let's make a guess. That's going to be about right here. So that's going to be where? -4. Actually, it looks like it's a little past -4. So let's go -4.5, -0.5, something like that. And then if we come over here, it's going to be 1, 2, 3, 3.5, 1.5. Oh, wrote it on the wrong page. Somewhere like that. If we estimated, we would have -4.5. Was it -1.5? And then 3.5, what? 1.5? If we just guessed. Okay? Just by looking at the graph. Oh. 0.5. Okay. That's just where they're intersecting. So explain, we're going to say the intersections of the functions. Okay? Where you estimate in part D, was your estimate in part D correct? Well, how would we solve that? Okay, we could plug them in, right? Just look at it, she says. Just look at it. It looks like I'm going to go back and look at this graph right quick. It looks like okay. My graph, I think, is a little bit off with my line because they check 2.5 and not 3.5 as x. Okay. So they plug in, they said 2.5. So let's do that. If we plug in 2.5 for x, what do we get? 2.5 plus 2 minus 3 equals 2.5 plus 4. What do we get? That's 4.5 minus 3, that's 1.5? No. Yeah, 1.5. What do we get over here? 1.5, right? That checks out. Now let's do -4.5. We do -4.5 plus 2 minus 3. Does that equal negative 4.5, opposite of that, plus 4. So this would be a what? 2.5 minus 3. It's going to be negative 1.5. No, negative 0.5. What? I was right? What are you talking about? No. And so, yeah, that's going to be negative 0.5. So there it is. Should have been 2.5, though, and negative 4.5. And that's how you check it there. See if you are correct. Plug in your x values because they should equal each other, right? Your y values should equal each other. 2. Let f and g of the function given by f of x is equal to x squared and g of x equal to x times the x absolute value. Ugh. Okay. So what happens? Now here, all you have to worry about is plugging in the correct for f and g. So if we find f of 1/3, that's just 1/3 squared, right? What is that? You don't want to do that. You want to leave that as a fraction. So what's that going to equal? What's 1 squared? 1. What's 3 squared? God. 9. So 1/9. Okay. Now if we plug in g of 4, was it 4? Yeah. G of 4, we would get what? What? Yeah, 16. G of 4 is equal to 16. Because 4 times the absolute value of 4 is 16. What about if we have g of a negative square root of 3? What does that equal? Negative square root of 3. No. If we did that, we would have negative square root of 3 times the absolute value of the square root of 3. Which would be negative square root of 3 times the square root of 3. What's the square root of 3 times the square root of 3? Stop saying it. It's 3. A square root times a square root is the square root of 3 squared. They cancel each other out. The square root and the square cancel each other out. It leaves you with a negative 3. Okay? So what is the domain of f? Why? Domain of f is all real. Why? Because it could be any number, right? What is the range of g? Why? Because it can be all real numbers. Now, evaluate alpha of negative 67 plus g of negative 67. So what is negative 67 squared? 4,489. And that's going to equal 0. So, x squared is just the opposite of x times the absolute value of x. Is that true? If it's a negative number, one of the numbers would have to be negative for it to be like that. Because if they were both positive, then you would just add them together. Right? Okay. So page 3. We roll in. Compare and contrast alpha of g. Okay, how are they alike and how are they different? So when x is positive, what's going to happen? They're both the same value, right? When x is positive, they're the same value. But when x is negative, what are they? So they're the opposites, right? Opposite values. Okay? F. Is there a value of x such that alpha of x plus g of x is equal to a negative 100? If so, find x. If not, explain why no such value exists. Think about it. Why? That's a true statement, but could you still get a negative 100 if both were not negative? What if one was a negative 200 and the other one's a positive 100? They would both be negative, but you could still get a negative 100. So what would we say? It is false, but alpha and g are either going to be both 0 or both positive numbers, right? You're not ever going to have anything that's going to be less than 0, right? So no, either alpha and g are 0 or both positive. Therefore, you cannot have that's not. They're not. Not that they're both 0. They are equal to 0. If we add them together, they're going to equal 0, right? Or they're both going to be positive, which means it can't be a negative. Sorry. So G says if there is a value of x such that x plus g of x is equal to 50. Okay, so can we get 50? How? Each one would, alphabets would need to equal. Alphabets would have to equal 25, and geovets would have to equal 25. So 25 is equal to x squared, and 25 is equal to x times absolute value of x. Well, square root both sides. X is equal to 5. And what would it be here? What would it be for g of x? It's got to be the same thing, right? X would have to be 5. Right? Everybody agree with that? Okay. Number 3 says a boy bought 6 guppies at the beginning of the month. 1 month later, the number of guppies in his tank had doubled. His guppy population continued to grow in this same manner. His sister bought some tetras at the same time. The table below shows the number of tetras T and N months have passed since they bought the fish. Okay? It says create a function G to model the growth of the boy's guppy population, where G of N is the number of guppies at the beginning of each month, and N is the number of months that has passed since he bought 6 guppies. What is a reasonable domain for G in this situation? All right, so let's write, first of all, we have to say G of N is equal to what? What? To the N power. Correct. So we can plug in whatever number of N we want, which is the months after having bought the guppies. So if we plug in 0, which means we are what? What? If we plug in 0 for N, that's going to give us what? How many we had in the beginning, which was anything to the 0 power is 1. So 6 times 1 would be 6. That's what we had in the beginning. That's how many we bought. After 1 month, we would have 2 to the first power, which is 1 times 6. 1. 2 to the first power is 2 times 6 is 12. Right? So we would have 12 guppies. Now, the domain would be what? It's got to be what? Why not real this time? But our domain is months. We would not count what? Half of months. Right? We don't want to know about half of months. We want to know at the end of the month. So all whole numbers. All right, go to page 4. How many guppies will there be 1 year after he bought the 6 guppies? Well, that would be G of 12 because we're talking about months. And our formula was 6 times 2 to the 12th. Ooh, what is 2 to the 12th? A bunch. 4,096. 6 times 4,096 times 6. 24,576. Wow. 576. A lot of guppies. A lot of guppies. Create an equation to determine how many months it will take to reach 100 guppies. Well, what's our equation going to be? No. We know what G of something is. What is it? What do we need our answer to be? Yeah, so 100 is equal to G times 2n, where we're solving for n, right? D, use graphs or tables to approximate a solution to the equation from part C. Explain how you arrived at your estimate. So since I'm not going to do this chart because it's or the table, the graph, because it's going to be too small. I'm going to make a chart over here. And it wants us to find how many for 100. So this is just going to be plug and play. N, G of N. Let's go with 3, 4, 5, 6 months. 3, 4, 5, 6. So let's plug it in. 6 times, not 12, 2 to the third. What do we get? Anybody do this? 2 to the third is 8, times 6 is 48. What's 2 to the fourth? Times 6, 96. What's 2 to the fifth? Times 6, 192. Oh, we can stop there, can't we? We could have stopped there anyway. We knew that it was going to be 5 because we were already at 96 after 4 months, right? So we knew that the next month we were going to have over 100. So we would say that it would take 5 months to have 100 guppies. Now we're going to have 192 of them, but it's going to take that 5th month to get over 100. Okay. E says, create a function T to model the growth of the sister's tetra population, where T of n is the number of tetras after n months have passed since she bought. Okay. So what did she do? His sister bought some tetras at the same time. Oh, so she bought 6 tetras, and then after 1 month she had 16. After 2 months she had 24. After 3 months she had 32. So what's the constant change here? Plus 8. So there's 2 different ways we could write this. Well, actually there's one way, but then we could do it. So let's do it. T of n is going to equal what? 8 times n plus 1. Because we're going up 8 each time, right? At 0, at the very beginning, how many tetras do we have? 8, because 0 plus 1 is 0 plus 1 is times 8 is 8. Now, after the first month, what's 1 plus 1? Times 8, 16. After the second month, 2 plus 1 is times 8 is 24. So it works out. Now, you could also write that as 8n plus 8. Right? Just do distributed property. It's the same thing. And once again, we're only going to have n equal whole numbers. We're not going to half a month. Talking about months here. Elf. Compare the growth of the sister's tetra population to the growth of the guppy population. Include a comparison of the average rate of change for the functions that model each population's growth over time. So, now, right now, without even doing anything, who's going to have a faster growth? It does. We're going to have a faster growth in what eventually? Guppies. Why? Because it's an exponential function. It is growing exponentially. The tetra is growing linearly. It's a constant change. Right. So the guppies will eventually win out. Guppies win out. They're going to start off a little slower, but they're going to catch up. I bet you it's going to ask us, when is it going to catch up? G, let's see here. Use the graph below to estimate the number of months in which pass. Oh, yep, see there? That's how it works. So, let's see here. We already know this. Let me see if I can do this here. Copy. I'm going to hopefully nope, I don't know how to do this. Oh, I can. Not. Maybe. Nope. Okay. I was going to try and copy and paste that graph that I just did. I already did the Guppy graph. Okay, and then we already had her other one, but I can't do it. Sorry. Okay. Let's look at, when we had the 3 for the guppies, we had how many? 48. 3 equaled 48. And for the tetras, that was how many for 3? 3 times 8 would have been 24, plus 8 would have been 32. For the tetras and guppies. So that would that's going to be when they're going to swap, because remember, the guppies are going to start out slower, so they're going to catch up during the 3rd month. Okay, so if you were to graph that, it would look something like too close. If this was 3, it's going to cross right here, the 3rd month. Okay, y'all understand that? If you graph it, the tetras are going to start out faster, but the guppies are going to catch up, where these are G and these are T's. And so they're going to cross at about 3 there. I want to hurry. I don't want to slow down. We still got a lot of work to do. Oh, 2. So yeah. If you use the table, it would look something like this. For 2s, you would have 24, 24. 3, we would have 48 and 32. This was the guppies, and these are the tetras. So it would take the 3rd month for them to catch up. Okay? So I says, write the function g of n in such a way that the percent increase in the number of guppies per month can be identified. Circle or underline the expression representing the percent increase in the number of guppies per month. So think about it. We were doing 2 to an exponent, right? Well, what would that be in percents? In a percent. We're going to have g of n is equal to 6 times 2 to the n. But what if we did that as this 2 as a percent? What would it be? What's 2 wholes as a percent? 200, right. So that would be 200% to the n power. So the 200% would be your percentage. Okay? That's how much of an increase. 200% increase is pretty good. Okay? All right, number 4. Let's see if we can. Oh man, there's still so much to do here. All right, number 4. It says, regard the solid dark equilateral triangle as figure 0. First figure of the sequence is the one composed of 3 dark triangles. The second is composed of 9 dark triangles, and so on. All right. So if we have figure 0, 1, 2, 3, and 4, how many dark triangles are in figure 0? 1. How many are in figure 1? How many in figure 2? How many in figure 3? Just multiply by 3. 27. And what's 27 times 3? 81. There we go. Now it says, given the number of dark triangles in a figure, describe in words how to determine the number of dark triangles in the next figure. Well, what did we do? We simply multiplied times 3. The previous that is not, yeah, it is. That is how you spell previous. The previous T, previous dark triangles. Okay? So create a function that models this sequence. What is the domain of this function? So T of it's called T of n is equal to what? Do you really want to multiply by 1? I mean, we can. Let's go with 3. What? What? N to the n power, right? 3 squared would be the second figure, and it has 9 dark triangles. Right? But n has to be what? The domain is what? Whole numbers. We're not going to have half of a figure, are we? All right, D says, suppose the area of the solid dark triangles in figure 0 is 1 square meter. The areas of one dark triangle in each figure form a sequence. Write an explicit formula that gives the area of just one of the dark triangles in the nth figure. Well, no, it's really not as hard as it sounds, believe it or not. So all you have to do is say A of n is equal to what? Instead of 3, because we don't care about dark triangles, we care about the area, right? Didn't it say the area was what? What did it say? 1 square meter, the area of one dark triangle in each term forms a sequence. Oh, okay. It would be equal to so think of it like this. What is the area of 0, 4? 0, 4. What is the area of figure 0? 1 square meter. How many triangles are they? There's one, right? Now, if we had one triangle, in figure 1, how many triangles do we have? No. In figure 1, how many triangles do we have? In figure 1, how many small equal triangles are they? 4. So that would be how much of the first triangle? What? Not 4, but what? Not 0.4. A fourth. There we go. It's just equal to 1/4. So that would be 1/4 n. That's all we'd have to do. Say 1/4 n. Think about it. For figure 1, right, we would have the area of one dark triangle would be how much? 1/4, because we broke the first triangle into 4 equal triangles, right? So each of those little triangles are going to be 1/4 of the original triangle. Good question. What would the next one be? Well, it's figure 2. So if you plug in 2 for n, what do you get? 1/16. She gets the right answer and goes, ugh. Like it hurt her to get the right answer. Yeah, good. All right, so it says E, the sum of the areas of all the triangles in 0 is 1 meter square. There's only one triangle in this case. The sum of the area of the triangles of all dark triangles in figure. Yeah, we won't do that one. Let's skip to number 5. Let's see how much we can get on number 5. We'll skip F2. All right, number 5 says the graph of a piecewise function is shown to the right. The domain of F is equal to, or is, -3 less than or equal to x less than or equal to 3. Create an algebraic representation for F. Assume that the graph is composed of straight line segments. Okay, so how many different equations are we going to look at here? 4. F of x is going to equal these 4. Okay? And we're going to have -3, 2 is going to be less than or equal to, what was that, -1? Oh, not equal to. We got to pick one. So we'll say -1, which means we're going to have -1 less than or equal to x less than 0. And then 0 less than or equal to x 2 less than 2. And 2 less than or equal to x 3.